Q6615-2. Removing the rotor force on a gyroplane can lead to A. A power pushover. B. Increased rotor RPM. C. Pilot-induced oscillation. The correct answer is A. When the rotor force is removed on a gyroplane, it can lead to a phenomenon known as a power pushover. In a gyroplane, the rotor provides the lifting force necessary to support the aircraft in flight. It also generates a significant amount of drag. The drag produced by the rotor acts as a balancing force against the engine's thrust, helping to maintain the aircraft in a stable attitude. However, when the rotor force is suddenly removed, such as during an engine failure or loss of power, the balancing effect of the rotor drag is lost. As a result, the thrust from the engine is no longer countered by the rotor drag, and it can cause the gyroplane to pitch nose down. This sudden nose-down pitch is referred to as a power pushover. It occurs because the thrust from the engine is now unopposed and causes the nose of the gyroplane to lower. The gyroplane may enter a dive if corrective action is not taken promptly. It is important for gyroplane pilots to be aware of the possibility of a power pushover and be prepared to react appropriately in the event of an engine failure or loss of power. Proper training and procedures should be followed to minimize the risk associated with this situation. To summarize, removing the rotor force on a gyroplane can lead to a power pushover, which is a sudden nose-down pitch caused by the unopposed thrust from the engine. 6618. Longitudinal and lateral control of a gyroplane in flight are affected by A. Anti-torque pedals. B. Tilting the plane of rotation of the rotor in the direction that control is desired. C. Adjusting the pitch of the rotor blades to the angle and direction that control is desired. The correct answer is B. In a gyroplane, the rotor system plays a crucial role in providing both lift and control. The rotor blades of a gyroplane are attached to the rotor hub through hinges that allow them to tilt or flap in response to control inputs. This tilting or flapping action is achieved through the use of the cyclic control. The cyclic control is a control input mechanism that allows the pilot to change the pitch of the rotor blades as they rotate. By tilting the cyclic control in a specific direction, the pilot can alter the angle of attack of the rotor blades as they travel around the rotor disc. This results in a variation in the lift produced by the rotor blades at different points in their rotation. When the pilot wants to control the longitudinal movement of the gyroplane, such as pitching up or down, they will tilt the cyclic control forward or backward. This tilting action changes the pitch of the rotor blades accordingly, causing the plane of rotation of the rotor to tilt in the desired direction. As a result, the gyroplane will experience a pitching motion in response to the change in lift distribution across the rotor disc. Similarly, when the pilot wants to control the lateral movement of the gyroplane, such as rolling left or right, they will tilt the cyclic control to the left or right. This tilting action changes the pitch of the rotor blades asymmetrically, causing the plane of rotation of the rotor to tilt in the desired lateral direction. Consequently, the gyroplane will experience a rolling motion in response to the change in lift distribution across the rotor disc. 6618-1. In order to maintain level flight laterally, as airspeed increases on climb-out after takeoff in a gyroplane, the pilot will need to increase A. Rudder pressure to the left. B. Cyclic pressure to the right. C. Rudder and cyclic pressure to the left. The correct answer is B. When a gyroplane is in level flight and the pilot wants to maintain lateral control as airspeed increases, they need to make adjustments to the plane of rotation of the rotor. This is achieved by applying cyclic pressure to the right. By tilting the plane of rotation of the rotor to the right using cyclic pressure, the lift produced by the rotor system is also tilted to the right. This creates an additional upward force on the right side of the rotor disc, effectively countering the rolling tendency of the gyroplane to the left. As a result, the gyroplane maintains level flight laterally. The action of tilting the plane of rotation of the rotor in the desired direction to maintain lateral control. This is the primary control input for controlling the lateral attitude of the gyroplane during level flight. The other options are not relevant to maintaining lateral control and can be disregarded. Therefore, the correct answer is adjusting the pitch of the rotor blades to the right, which tilts the plane of rotation of the rotor in the desired direction to maintain lateral control. 6620. A gyroplane will have the greatest tendency to roll during A. Horizontal flight at high speed. B. Climbing flight in which forward airspeed decreases. C. Descending flight in which forward airspeed decreases. The correct answer is A. When considering the tendency of a gyroplane to roll, it's important to understand the factors that influence roll stability. In this case, the question asks about the situation where a gyroplane will have the greatest tendency to roll. A gyroplane will have the greatest tendency to roll during horizontal flight at high speed. This statement is correct, and here's the reasoning behind it. During horizontal flight at high speed, a gyroplane experiences increased aerodynamic forces acting on its wings or rotor blades. These forces include both lift and drag. The lift force acts perpendicular to the rotor or wing surface, while the drag force acts parallel to the direction of flight. At high speeds, the gyroplane generates a significant amount of lift, which creates a rolling moment around the longitudinal axis of the aircraft. This rolling moment tends to roll the gyroplane to one side. The higher the speed, the greater the lift force, and consequently, the greater the rolling tendency. The other options are not relevant to the question at hand, as they involve specific scenarios where the forward airspeed decreases, which typically result in different flight characteristics. The focus of the question is on the gyroplane's tendency to roll, and this tendency is most pronounced during horizontal flight at high speed. Therefore, the correct answer is horizontal flight at high speed, as it is the scenario where a gyroplane will have the greatest tendency to roll. 6699-1. A 1 per revolution vibration in a gyroplane indicates which condition? A. Rotor blades out of balance. B. One rotor blade out of track. C. Possible onset of retreating blade stall. The correct answer is B. A 1 per revolution vibration in a gyroplane typically indicates that one rotor blade is out of track. This means that one of the rotor blades is not properly aligned with the others, causing an imbalance in the rotor system. As the out-of-track blade rotates, it creates an uneven distribution of forces, resulting in a vibration that occurs once per revolution. This type of vibration is often attributed to an issue with the tracking of one rotor blade. Tracking refers to the alignment of the rotor blades along their path of rotation. When a blade is out of track, it means it deviates from the desired alignment, leading to an uneven distribution of lift and drag forces. The imbalance caused by the out-of-track blade results in the 1 per revolution vibration. As the rotor spins, the misaligned blade generates varying lift and drag forces during each rotation, causing the vibration to occur at the same frequency as the rotor's revolution. It's important to address and rectify this issue promptly, as an out-of-track rotor blade can affect the overall performance, stability, and smoothness of the gyroplane's flight. Maintenance procedures and adjustments are necessary to realign the rotor blades and eliminate the 1 per revolution vibration.